Welcome back everyone. In the previous video we saw about the state diagram. This was the state diagram which we understood and which we drew. Now in this second part I'm going to show you how to write a simple Verilog code. I'm not showing you a pre-written code. I'm going to write it now and explain it step by step. Also this video might be a little bit long, but it's better if you understand it. Now firstly, whenever you write a Verilog code, you start with module, then you write the word, when you write the, oh sorry, since it's word, so it's taking small. Now, we need to define the module's name. We can take it as any name, like let's take VM. Okay, let's give a little bit indentation here. Now, inside the parentheses, we have to pass the parameters. We have to pass our inputs and outputs. So now it doesn't matter in which order you pass your inputs and outputs, because anyhow you're going to define what are your inputs and what are your outputs. So first of all, the most important thing in a state machine, in a finite state machine, is clock. We will define it with clock. Without clock, we cannot move from one state to another. The clock is very much essential. Similarly, reset is also input, which is very much necessary, because suppose if you are stuck at some S25 and the power goes off, we should be able to reset the vending machine, reset the whole finite state machine. So that is something which we should not forget. And then comes our input. That is, let us define that by IN. So these are our inputs. That is, the inputs can be any of the three: nickel, dime, quarter. Then our outputs will be out. That is what out we are getting, whether it will be 1 or whether it will be 0. And finally the balance. What's going to be our balance? Then the second thing what we need to define is what are the inputs and what are the outputs. So we have given here input. Input is clock and reset, and also we have to define the input, that is the vector, that is 1 is to 0. Okay. Yeah. Now the reason behind defining this vector is because we are having 4 possible inputs. If I write it in a comment, so 0, 0 will be used for no coin, and 0, 1 will be used for a nickel coin. 1, 0 will be used for dime, and finally 1, 1 will be used for quarter. So that is the reason why we have defined the vector 1 to 0. That is, in this we are having that means two states. So 0, 0, 0, 1, 1, 0, 1. Since we had total 4 possible states, 4 possible inputs, we'll have to take the combination of 2 2's. Because suppose if we take only one, not a vector, just one bit, so it can be either 1 or 0. But if we take 2 bit, it will be like 0, 0, 0, 1, 1, 0, and 1, 1. Now we'll have to define the output. And if you are familiar with Verilog programming, you know that we define all the outputs in a finite state machine as reg. Finally, it's out. Okay. The next thing is we have to define our balance. That is output reg. Now the balance is not necessarily that it is not necessary that it should be in cents only. That is, it should be in 5, 10, 25. It is not necessary. Balance can be, since we are starting from balance 5, 10, 15, 20. So writing it in binary form is not feasible because we will have to write 20 and so on. So we will try to write it in a decimal format. For that, we will have to define balance as 4 down to 0. Balance. Now comes the next important thing is parameter. So parameter in a Verilog is basically a constant. Now whatever the states we have is 5, is 10, is 15, we all need to give this some constant value. Starting from S0, let us suppose S0 is some 0, then S5 is some, S5 is 1, S10 is 2, S15 is 3, and so on. And so on till S60 is equal to 12. So having defined this, now we need to define one more thing, that is, we have to define some registers, and we will define them as 3 down to 0, CS, and reg 3 down to 0, NS. So what is this CS and NS? CS and NS is nothing but the current state and the next state. We will have to define this because we cannot every time specify that this S5 is indicating the current state, and for this problem S10 is the current state. No. So whenever we have to write a case statement here, obviously. So current state will tell us on which state we are in. We don't have to take the name of it, and the next state will tell us where should we go from that particular state. After defining these current states and next states as registers, that is, registers are some basic what you can say identifiers which will store the value. They are the keywords which store the value. Now this is an always block that you need to include in every final state machine you're going to draw. That will be, pause H. That should be a bracket there. So it should be pause H clock, then begin if reset CS is equal to 0, and else CS is the next state, and finally end. So what did we do in this always block is, we have defined always at pause H clock, that is always at the positive edge of the clock, that is at the positive trigger of the clock, we should execute this loop. And this loop when the clock has started, so whenever, if reset, here if there is no condition, if reset is equal to 1 or if reset is equal to 0, there is no condition, just written as reset. That means if the break condition is true, that is if reset is equal to 1, if you press reset, then your current state, whichever state you may be in, is S5, S10, S20, S60, any state you may be, you should go back to your normal state, original state 0. Or else, if you have not pressed reset, then with the clock, your current state should keep on changing to the next state. Now one thing you might be noticing is why I have written less than equal to symbol, why not equal to? So if you have the knowledge of blocking assignments and non-blocking assignments, you would be able to appreciate that. So just a brief overview of why did I use this, because in a non-blocking assignment, all the statements execute simultaneously irrespective of the time, irrespective of the previous sequence. Blocking assignments will block the execution of one statement, the previous statement, but the non-blocking assignment will not do that. This statement will execute for its own condition and this statement will execute for its own condition. It is not like that after this condition is executed only, then this condition should execute. So that is the reason why we had written a non-blocking assignment, why we have used non-blocking assignment. Now after ending this, now comes the real code that we have to write. We again start with always, and this time we don't write any positive edge clock, we just put asterisk so that it is for all the conditions. That is, we don't need to specify the parameters inside it. It is applicable for all the parameters. Next, let us put a case statement. Why are we using case statements here? We could have used if else, but nesting of if else would leave us more confusing, and there are not just 2 or 3 states, there are a total of 12 states. So that is why the current states should be keep on moving, and we have to use the case statement. Now let the current state be S0. Now let me bring this a little downwards. So I have pasted a photo here so that we can easily write down the code by looking at that. So here, take a look at this one. If you are at the reset, now if your input is a nickel coin, what we have defined the input for nickel coin is 0, 1. If your input is 0, 1, then you move on to the next state. Whatever the next state may be, you move on to the next state. There is one more possibility. You will move to the next state, which is S5. There is one more possibility that instead of nickel coin, if you enter a dime coin, the dime here we have denoted it with 10. If your input is 10, you will move to S10. If your input is 0, 1, you will move to S5. If your input is 10, you will move to S10. And if your input is 1, 1, you move to the quarter state as defined earlier. If your input is 0, 0, you will remain at your own state, because 0, 0 indicates no coin. That means you have not inserted any coin and you will remain on whichever state you are. So for the S0, here now we need to write our if conditions. So if IN, that is our input, is 2 tick binary 0, 1, then let's pick, okay, we'll write it in one line because we'll have to write many lines here. Begin and next state will be S5, then end. This is one condition. Else if IN is equal to 2 tick binary 1, 0. In this case, our next state will be S10 and finally end. Else if IN is 2 tick binary 1, 0, will begin, and the next state will be S25. As you can see here, the next state will be directly S25, and we'll write it as end. Finally, we'll have to include an else statement too. We'll try to give in some indentation so that the case statement is separated from the else if nesting. We'll write else, the next state is the previous state, that is S naught. Yeah. Now, this is the first possibility, that in the case statement you've written CS, that if CS will be equal to S naught, then these statements will get executed. Now, if you are at the second statement, that is S5, suppose you are at S5. Now, from this you might have guessed now, if you insert a 0, 1, that is if your input is 0, 1, and if you inserted a nickel coin, you will move to S10. And else if you enter a 1, 0 coin, that is a dime coin, you will move to S15. If you insert a 1, 1 input, that is quarter coin, then you will move to S30. So if you try to write for the S5, so you can see for S5 it will look like this. That is, if the input is 2-bit 0, 1, you will come to S10, and if not, you will move to S15. If your input is 1, 1, you will move to S30. And finally, we should not forget the else statement, which is next state else. If you do not insert any coin, then you will remain at S5 only. You will not go to reset back. Okay, because you will remain at that state only. Now similarly, for each state you will have to take a look. You have to think. For S10, you can see that if your input is 0, 1, that is you will move to S15. If your input is 1, 0, you will move to S20, and if your input is 1, 1, you will move to S30. So you can go on till S35. So you can try it out. I'm just going to write down it. So here you can see that we have written for S10, S15, S20, S25, S30, and S35. I will be giving the link for the code in the description. You can verify it later. But now we'll have to the code for S40 is not similar to what we have written in the previous examples. Now for S40, now when we consider the case S40, here you can see for S40, here in your S40, you don't have to move to a next state. So that means you don't have to put any if or else conditions. For S40, you don't have to move to any next state. So instead of writing the if else condition, you can directly write from the begin stage. Begin. Now the next state will be obviously S0, because once you reach the S40, the only way to stop this is to reach back the reset state. So when you go to an S, that is the next state is S0, your output will be 1. As promised, your output will be 1, and your balance now will be, we'll have to write like this, 5 take decimal 0. So that is the reason why we defined it 4 down to 0. It's 5 tick decimal 5 tick decimal 0 and end final. Similarly, when you write for S45, you start with begin, and your next state will obviously be the the reset state. Your output will be again 1, but your balance will be 5 tick decimal 5, because your balance will now be 5. You have to return the 5 change. Similarly, you can write for S50, S55 and S60. After that, you can close the case, that is end case, and then finally end module. So this is our complete code what we have written. It was very simple. First you need to define your inputs and outputs, then you have to define the parameters, then you have to define 2 registers for your current state and next state, then you have to write this always block so that you are generalizing it, so that whenever you're pressing the reset it should go to the 0 and else it should continue with its operation. Then for each case here for S5, S10, S15 we tried to draw all the possibilities, that what should we do to move to the next state, what will happen if we don't give the input, will remain at that state, and whether that state is producing any output. So we saw that till S35 we saw that there was no output, but as you started writing for S40 you found out that there are no if else conditions and only we have to write only the outputs, and that is we have written the balance and the decimal outputs. Then we finally ended the case and then the module. So this is the end of the Verilog module. And now to write the test bench, it's very simple. Whatever the name of the module name is there, you write it as VM, and then you don't pass any parameters inside the bracket because it is just a test bench. Then whatever you have defined as inputs, you will now define it as registers, and whatever the outputs you have defined, you will now define it as wires. Then you write the module name VM UUT. UUT is unit under test, or in place you can write circuit under test, and you pass the exact parameters that you have included in the name, that is clock, reset, in, out and balance. Then you initial begin, then you set the clock to 0 and reset to 0, that is you initialize, and then after #5, that is after 5 seconds, you put the reset as 1, and then another 5 seconds you bring reset back to 0. And this is just to test whether the reset is working or not, and to just initialize the finite state machine. Then you end it, and then this is a statement which keeps clock ticking for every 5 seconds. That is, for every 5 seconds it will be positive, and then after every 5 seconds it will be negative. That is, it will be exactly a replica of the previous cycle but in the negative direction. Then initial begin. Now this bench is very simple because you just need to give the inputs. First, let us initialize our input to 2-bit 2-tick binary 00. That means at this stage we have not inserted any coin. Then after 40 seconds we want to insert a nickel coin, that is a 5-cent coin, that is input is 01. Then after another 10 seconds we insert a dime coin. So here that means a dime coin is inserted after a total of 50 seconds in this loop, because these are blocking assignments and the execution of the second statement will happen only after the first statement is executed. Then after another 10 seconds, that is in total after 60 seconds, we are inserting 2-tick binary 11, which means a quarter coin or a 25-cent coin. So as you can see, 5 plus 10, 15 plus 25 will give you 40. That means our output will be 1 and our balance will be 0. We know this, but we have to test this. And now if you do not stop it, It will keep on going unless you switch off the power or you break by any means. Then end module. So this is a very simple test bench. Now let me show you how the simulation works if you simulate it in any Verilog supporting software like Model Sim, Xilinx, etc. So in this, you carefully observe here. Now these are our parameters. Now let us first talk about the clock. A clock, after every 5 seconds the clock is getting off, on, then after another 5 seconds it is getting off. Since we defined it, so it will keep on going because we have defined it in an always block. Now input. Firstly, we have defined our input as 0. Then we have defined our input as 0, 1 for after 40 seconds. So after 40 seconds our input will be 1. Then after another 10 seconds our input will be 2. And after another 10 seconds our input will be 3. Now if you might have noticed that here after 60 seconds we have declared our input as 2-tick binary 1 1. After that, after 100 seconds, that is, which is more than 50, 60 and 60 plus, so after a lot of time we are stopping our finite state machine, or stopping our input. That means till 100 seconds, till more than 100 seconds our input is 1 1 only. That means we are keep on inserting our quarter coin till more than 100 seconds. So that is the reason why this input is very long. It is going forever. After 160 it is going to terminate. Yep, exactly, after 160 it is going to terminate. So which means now, as you can see, reset. Firstly, we have, after just 5 seconds we have made the reset as 1. Then for the rest of the time we have made our reset as 0, as it is evident from here. Hashtag 5 reset is equal to 1 and hashtag 5 reset is equal to 0. Now as you notice that as soon as we enter a nickel coin, that is when our input is 1, we will move to S5. That is, we also define in our code the parameters that S5 is denoted as 2. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we are starting from 0. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the numbers that we defined in the parameter. If you can take a look at the code, so which means that our current state, which was on 0 first, now it will move to 1. Because our input is 1, our current state will also move to 1. Now our input is 2. That means after the nickel coin we have inserted a dime coin. That means from S5 we are going to move to S15, which is 0, 1, 2, 3, the number 3. So our current state will go to 3. After inserting a nickel coin, we have inserted a quarter coin. That means we are at S15. Now we have inserted a quarter coin. That means, it will go to the 10th state. Sorry, the 8th state. So that is the reason why our current state is gone to 8. Now after you go to 8, you will return back. That is, this is the 8th state, right? As you can see, carefully notice here, it is going till S40. After S40 is reached, our current state will go back to a reset. That is, after 8, current state has gone back to 0. Now as I told you that this tree is going forever till 160 nanoseconds. That means after we have reached the reset state, we are keep on inserting the 25-cent coin. That means after we reach the reset state, we will now move to 25, Then again 25 we will move to S50, that is, this is the 10th state. 0 we have moved to 5th, then we have moved to 10. Then again from 10 we'll move back to 0. Then again from 5, 10, 0, 5, 10, 0. Now it keeps on going until we terminate it. Similar is the case for the next state. As you can see 1, then the next state is 2, so it will move on 2, 3, the next state is 5, so it will move on to 5, then 8, then 0. The next state for it is 5, so it will move on to 5. The next state for 5 is 10, so it will move on to 10. So current state and next state are similar. Now when you take a look at the output is not defined here because we are on the intermediate states. Now as soon as we reach the 0 state, our output will become 1, and the balance is 5 tick HXX. That means the balance is not defined here. Now as soon as we reach the 40 state, that means our output will be 1 but our balance will be 0. Then we have keep on inserting the 25-cent coin, 25, 25. Now as soon as we reach 10 state, our balance will be 10. That is exactly, our balance is 10. So this is the simulation, and in this one also it is similarly we are keep on inserting 25-cent coins. This part is being shown as a separate here. You can, so this is how you do. So I hope you like my explanation, and there are many problems apart from the water vending machine you can try to solve. I will put it on my website, and if you have any doubts and if you want more videos in this manner, please comment in the comment section. Like, share and subscribe. Thank you.